Hello students, let us solve a problem from NEET UG Paper 2021. Here is the problem. The problem states that a thick current carrying cable of radius capital R carries a current I uniformly distributed across its cross section. The variation of the magnetic field B due to the cable with distance R from the axis of the cable is represented by one of these four graphs, and you have to find out the correct option given here. So to find out the answer for this question, you need to find out the variation of the magnetic field inside and outside the cable. And while calculating the magnetic field inside and outside the cable, you can use the Ampere's circuital law. Let us first understand and calculate the magnetic field inside the cable. So to find out the magnetic field by using Ampere's circuital law, you have to first draw the Amperian loop. So since we are calculating magnetic field inside the cable, we draw an Amperian loop inside the cable here, and that is the circular Amperian loop. And Ampere's circuital law states that B dot dl is equal to mu naught into I enclosed. So here this I enclosed is the current which is passing through this Amperian loop and perpendicular to its plane. Now let us solve this. Left hand side by symmetry we can write B into 2 pi r. Now we have to find out what is current passing through this Amperian loop. So it is not the I which is passing through this Amperian loop. So we have to find out first what is current density or current per unit area and multiply the area of this Amperian loop so that you get the current passing through this Amperian loop. So this is what we get, I into small r square divided by capital R square. Now these two equations if we equate, we will get the magnetic field inside the cable. So which we get as mu naught into I into R divided by 2 pi square capital R square. So as a whole, you understand that the magnetic field inside the cable varies directly proportional to R inside the cable. Now similarly, we can find out the magnetic field outside the cable, and to do that we have to find out, first of all we have to draw the Amperian loop of radius R. In this case also R is greater than capital R. That means this is exterior point, and in this case same formula will be applying here. And the left hand side by symmetry we can write B into 2 pi r, and the current enclosed by this Amperian loop will be the whole current in this case. So we can directly write down the magnetic field outside the cable as mu naught into I divided by 2 pi r, which means the magnetic field outside the cable varies directly inversely proportional to R. Now we have got the variation of the magnetic field inside the cable and outside the cable also. Now let us see which one among these four is depicting the same thing. So the magnetic field inside the cable varies directly proportional to R, and that will continue up to the radius, and then outside the cable it will be varying as 1 by r. So the third option is actually giving you the correct variation of the magnetic field with the distance from the axis of the cable. So the correct option will be the third option. Thank you.